Hi Jonah, here's your recap video. I know I sent you a couple of videos already which explain, well, cover what we did anyway, which was multiplication of 2-digit, 3-digit and the 4-digit, if you wanted to do that as well. And I also sent you how to solve a cubic video, which was obviously very similar to the lesson. So I'm not going to do that all over again. So what I thought I'd do, what would be better, is just kind of recap in general what we did and then do some questions which prove or demonstrate how my way of doing it will work for anything, and just to get the concept across that way. So that was for cubic wise, and circles wise I just thought I'd show you a typical question that you might be able to tackle on your own, and I want you to do it for yourself and get back to me on what you did, on the answers, and if you struggled with it or not, or if you found it easy, whichever. Okay, so solving a cubic, as we talked about at school, you've may have missed it, but you would have been taught long division to do that. But remember, the first step to solve a cubic is just to figure out what one of the solutions is, or have a guess. So here's an example of one to start off with. Let's get the right page, that'll help. No. There we go, x cubed plus 6x squared minus x minus 30. Okay. So let's say I want to factorize that. Now, I got this from an exam. I'll just find the question. Here it is. So you're given this f of x is equal to all that stuff, and it's question 1. Use the factor theorem to find the root of f of x is 0, and hence factorize completely. So that's exactly like I said. This thing of trying to find factors has got this grand title of the factor theorem, which just means we're trying to find the things that multiplied to get that cubic, so 3 brackets, or a bracket in a quadratic. So we're going to equate it to 0, and then hence factorize and find the other roots. So, like I said yesterday, it was yesterday. We just have a guess. So we're going to choose numbers that are factors of what number? Have a think. Hopefully you're thinking minus 30, because we don't want to just try anything. So the obvious choice would be 1. I can see straight away that 1 is not going to work there, because 1 plus 6 plus minus 1 minus 30, it's not going to give me 0. So try something a bit bigger. Maybe 2 looks better. So let's go with 2. So 2 cubed. Where's my thing? So we've got 2 cubed, which is 8, plus 6 times 4 is 24. Oh, this is looking good. Minus 2 minus 30 is 0. So that's good. So 2, x equals 2 is a solution. So what's the factor going to be if x equals 2 is a solution? So to get the factor, just going to move the 2 across, and it's going to be x minus 2. So next step is just draw a line across the top and put that factor in, so x minus 2. And we're going to discover the quadratic from that. Remember, it's going to just appear on top of that. And it's quite straightforward. You can see straight away it's going to be x squared. We'll get to that in a minute, but x times x squared is going to give me x cubed. And on the right hand side I can see straight away it's going to be plus 15 to get minus 30. So once again we've got to get minus x, just a coincidence that this number keeps going up. So we've got 15x there, so I need to get minus 16x to get down to minus 1x, don't I? Because I've got 15x here in this multiplication, so I need to have an x term there, which is going to give me 16x. Since I've already got 2, I just need 8x, so it's going to be plus 8x because it's minus 2. And there we go. So that's the hard bit of it done. And the final part, quite easy, just going to be x squared, because of the x cubed. It's going to come from the x squared times x part. We can confirm that's correct by just doing the Union Jack. So 8x squared is that bit there, 8x times x is 8x squared, minus 2x squared is 6x squared, and there's nothing there. So we're expecting 6x squared here, and that's what we got. So yeah, that makes sense. If I was to multiply this by this, I would get that. So I found a factor, x minus 2, and then all I've got to do now is factorize the quadratic. You can probably see from sight what that is already, or can you? So pause it and do that yourself. Okay, so you should have unpaused and found that you've got, I hope you are pausing and unpausing, you should have got x plus 3 and x plus 5, because 3 5 is 15, 5 and 3 is 8. Yeah, so you should have got that in a bracket. You could have done it above it. That's what I do. If I had room, if I thought I had enough, I would have put 3 5s and x, so x plus 5, and x plus 3. I would have done it in reverse order as well. I would have done the numbers first. 3 5 is 15. Could have been minus 5, minus 3. Could have been 15 and 1. So there are a few options there, but because it was 8, 5 and 3 just lapped out at me. So there we go. So there are the three factors: x plus 5, x plus 3, x minus 2. So the solutions are going to be what? Pause the video. So of course, x equals 2, and the other two are going to be minus 5 and minus 3. So the next part of the question asks you to sketch it. So we did that yesterday as well, and we're just going to put those values in. So 2, minus 3, minus 5, so that's about there, just a rough sketch. And it's going to cross at minus 30, so this is going to be a bit weird for scale, but just to give you a sense of what's going on. So as you can see, it's going to go down there, hit there at minus 30, come back up through 2, and look something like that. The final part I'm going to leave for you to do as well, so please have a go at that, and I'll see if you can do it, and get back to me what the answer is. It's to do with, remember, the completing the square that tells us about translation. So what would happen if this graph was moved one to the right? What would we do to the x term to achieve that? And think about completing the square. Remember, it teaches us what happens when we can move something left or right or up and down, and how to do it. So that's the first one. Okay, so hope you can see that that's a typical exam question. I actually got that from a 2010 paper. I think it's a different exam board to you, but that was a question. And here's another one. So next one up is this one here. So we've got this graph. Fig 12 shows the graph of 4 over x squared. On the copy, draw accurately the line y equals 2x plus 5. Draw a straight line. What's the gradient? What's the intercept? Okay, hopefully you got 2 and 5 for that. Hence, find graphically the three roots of the equation this equals that. Okay, so what is algebra for? That's what I put there in my little usual list of things we're covering. What algebra is for, and it is, hopefully you're saying, to find out where two lines cross. So that's exactly what this question asks. Where do these two lines cross? So sketch that line 2x plus 5 on there, and tell us where they cross, which is known as the solutions or the roots. So I've drawn a graph of that for you to look at. You can just about see it. It's just a bit of bad luck. It's not quite in the shot. It's just about. The red line is y equals 2x plus 5, and the blue line is the 4 over x squared. And you can see it crosses in 3 points. One there, so it looks like when x is minus 1. Sorry, x is minus 2. One there, and one there. So it looks like a bit less than 1 there, a bit less than minus 1 there, and it looks pretty much like minus 2 there. So that's interesting. Got a nice number and two not very nice numbers. So I wonder how that's going to turn out. So going back to the question, we've got that part done. Part 2. Show that this equation you have solved may be written like this. So to do that, I think you can probably see that we're just going to rearrange it. So just multiply by x squared, it's going to give 2x cubed plus 5x squared, which is that part there. And once we've done that, we're going to move the 4 over, and that's going to equal 0. So we're just doing BIDMAS in reverse there. We've got this little hitch problem, which is that there's an x squared in the division, so we need to get rid of that division by multiplying by x squared first. And then we're going to move the 4 over, because we ask, basically we're trying to make 0 the subject of this equation. Verify that x is minus 2 is a root of this equation. So we're going to put minus 2 in there and see if it gives 0. And hence find the other two roots. Now it says in exact form. And you might think, exact form? What does that mean? So there's some. Remember the two other solutions. We know x is minus 2 is one. Looking at the graph, remember, it looked like minus 2 on here. The other two are a bit weird. They're not nice numbers. Okay, so that's a couple of hints that this is not going to be a factorizable quadratic that we're going to get, but we'll see that in a second. So we're going to do the same thing as normal. We already know that minus 2 is a solution, but I'll just check it. So minus 2 cubed is minus 8 times 2 is minus 16. And then I've got minus 2 squared is 4 times 5 is 20. So 20 minus 16 minus 4 is 0. Yep, that works. X is minus 2 works. So then we know that x minus 2 works. I can put that as a factor. Now when I wrote this, I just wrote, I forgot to leave a gap for the 0x term, so there should be a gap there, which might make it easier for you to do if you do it yourself. Doesn't really matter, to be honest, so I'll just write x minus 2 for now. I'm going to line up the number, so it's obvious what this number's going to be. It's going to be plus 2, isn't it? And we're just going to find the quadratic in the same way. So here, there is no x term, so we can tell straight away what x term is going to be here. It's got to be x, isn't it? Because we need plus 2x minus 2x, which gives 0. And then I've just got to figure out what the final term is of the quadratic. Here, we've got 2x cubed instead of x cubed, like we've had so far. So instead of it being x squared here, it's going to be 2x squared. So the quadratic we're going to get is 2x squared plus x plus 2. And looking at that, you might think, can I factorize that? How can I get 1x from 2 and 1 and another 2 on the x squared? And you can't. So as we saw, we're not getting a factorizable quadratic. That's what was hinted at with the strange solutions and the question saying put the answer in exact form. It wouldn't say that if it was a factorizable quadratic, because you get nice numbers. Okay, so let's just check that is correct. 5x squared will be our checker to make sure it's correct. So if we do the union jack, it'll tell us. So I've got x squared there. That's fine. And then I've got minus 4x squared there. So that doesn't add up to 5. So that tells me that something's gone wrong. So what's gone wrong? Let's have a look at that. I must have made a mistake. Let's have a look at the question. Did I copy it across wrong or something like that? 2x cubed plus 5x squared minus 4. Oh, I know I did, didn't I? X is minus 2 is you did this yesterday. X minus 2 is x equals minus 2 is the solution, so the factor is plus 2. So that makes that minus 2 there. So that's why. You probably spotted that yourself. You're probably going, what are you doing? Making a mistake. Hopefully you did. Hopefully you saw that and thought, is he going to realise this is wrong? So is that going to affect things? Well, minus 4 there, and then 0x still here because it's 2x minus 2x. 2x cubed there, that's fine. So now, so it's good that happened again. So 5x squared, is it going to work? Yes. Plus x squared plus 4x squared plus nothing in that corner there, which is 5x squared. So that's all good. So to find the other two solutions, we need to solve this quadratic. And as we said, it's probably not going to be factorizable. Can you remember how to check whether a quadratic is factorizable or not? If not, I will show you again. It's got something to do with the discriminant. Anyway, let's solve it. So my preferred way of solving a quadratic is to complete the square. So first of all, take the 2 out of the front. So it's going to be x squared plus a half x. Sorry about this, my mouse is really rubbish. I'm having to use the pad and it's not as good. So yeah, and then I've got a complete square on that. So if you want to have a go at that yourself and solve the quadratic, I'll leave that for you to do. Okay, I know you know how to complete a square and solve. So again, let me know what you get for that. Okay. You're going to get these 3 solutions, and I'm pretty sure that you're going to get these values. Round about minus 1.5. But we don't want to write the answer as decimals because it says in the exact form, so you just need to leave it as square roots or surds. So just leave it in that form. So you're going to get something like, where is it there? So you're going to get some middle figure, so something like minus 0.5, plus or minus, it could be a quarter actually, minus a quarter, plus or minus some amount, some square root. And that'll be because of the line of symmetry between the two. There's a kind of a quadratic there, symmetry. So there'll be something like minus a quarter plus a square root or minus a square root are the 2 solutions. But as I say, let me know what they are, okay? Alright, so that's that one. So what's that question? Is there anything else we need to do on it? By drawing a suitable line, find the number of real roots of the equation x cubed plus 2x squared minus 4 equals 0. Okay, so I want you to have a go at that for me as well. What's the difference between x cubed plus 2x squared minus 4 and 2x cubed plus 5x squared minus 4? And from that, figure out same thing, just give me some more algebra. You have to equate them and solve. So have a go at that yourself and get back to me on what you get. Okay. So the first 2 questions that I've shown you are applications of the same ideas, the factor theorem, solving a cubic using that technique, generating the quadratic, and then solving the quadratic. The third question I want to show you is, I think it's on this paper. Oh, other one. Here it is. Number 6. If you were given that the coefficient of x cubed in the expansion of this times this is 29, and when x cubed plus that is divided by x minus 3, the remainder is 59. Find the values of k and m. So notice in both of them there's a k and an m, but you don't know what they are. So this is an example of the remainder theorem, the grand title of when you divide something by something that's not a factor, it won't go in. So when that cubic is divided by x minus 3, it tells us that x minus 3 is not a factor. Okay, that's all. So remember, this is a bit difficult to divide using long division, so it's another reason why long division is not very much used. So instead, what we're going to do to figure out what can we do with this information, these 2 pieces of information. So first one, coefficient of x cubed in the expansion of this is 29. We're going to multiply those brackets, okay? And because it's 3 by 2, 3 terms by 2 terms, we're just going to use the 3-digit method. So let's get on to that. Here it is, something I prepared earlier. So just talk you through it. So that's the cubic times by 2x squared plus 5. Now again, you'll notice that the 2x squared is in the wrong place. It should be further up, and the x cubed in the wrong place should be further up because it should be number x squared, x cubed. But it doesn't actually matter. The clever thing about algebra is that it doesn't really matter about order or anything like that. As long as that you use the same technique, you're going to get the right answer out. Which is pretty cool. So, talking you through this, the right-hand column is going to be 5m. Then we've got the cross. Don't panic about the fact that it's not going to add up. It's because of the different powers. So we've got that thing here is going to give 5kx. So I've written that down. This one's going to give 2x squared m, or 2mx squared. That's that there. Then we have the union jack, and this is going to give a cubic because I've got 2kx cubed there, and we've got 5x cubed there, and nothing there. And adding that together, it's going to be 2k plus 5, lots of x cubed. So I've written that as slightly to the left, but you can just about see it, 2k plus 5 x cubed. I could have written them separately at first, like I did here, but I just wrote them together because I know that they're going to add up. It says in the question that the coefficient of x cubed, the coefficient of x cubed means the number times by x cubed, or the thing times by x cubed, is 29. So that means that 5 plus 2k, sorry, yeah, 2k plus 5 or 5 plus 2k is 29. So that's a true statement, isn't it? We could continue multiplying, so I could do a cross here, but here is going to give nothing, and here is going to give x to the power 5, or the magnitude of that, 2x to the power 5. That's more than I want, and then here is going to give nothing. So it's just this part I'm going to need. That's all that's going to generate x cubed. So from that piece of information, I know that 2k plus 5 is 29. Because I've got two unknowns, that's sort of screaming at me to use algebra, simultaneous equations, so-called, or trying to find out where two lines cross. Same thing. So we need the other piece of information to tell us something more information about k and m. So when it's divided by x minus 3, the remainder is 59. That means if we put 3 in there, it's going to give 59. So that's what I've done on the next page. So 3 cubed, x cubed plus, it's going to be 3 cubed, and then it's kx, so it's 3k, plus the m is 59, and I've just moved 27 across. So 3k plus m is 32. So I've got two statements, 3k plus m is 32, and the other one, oops, one page, 2k plus 5 is 29. So straight away I can figure out what k is. K must be 12, isn't it? Because 24 plus 5 is 29, so k is 12. And if k is 12, it's 36 plus m is 32, m must be minus 4. So k is 12. And m is minus 4. So all those three questions, we've achieved the answers without doing long division, and using our knowledge of the factor and remainder theorems and understanding that algebra is to find out where two lines cross. That's what all those questions were about, and it's something that's very important to understand. Okay, so just a brief recap of the other bit we talked about yesterday, which was circles. So very briefly, circles was, you can remember, it comes from Pythagoras' theorem that just a constant distance away from it, away from the origin, can be described as x squared plus y squared plus r equals r squared. And then our typical question is to find out where two lines cross in terms of the circle. So where does a line cross a circle? And there are three possibilities. Can you remember what those possibilities were? So just pause for a second. So either the line's going to cross in two places, like we had with the cup and the pen, or it's going to cross in one place, so it's going to touch it, which is tangent to the curve, or it's not going to touch it at all. So those three situations are two solutions, one solution, or no solutions. And that's very reminiscent of quadratics, because there are three kinds of quadratic. Either there are two solutions, one solution, or none. And that's actually just the same question. When you equate a circle to a straight line, you'll end up with a quadratic, and then you just have to solve that quadratic. Whichever one it comes out as, two solutions, one solution, or none, will tell you the situation. Because algebra also tells us if lines don't cross, never mind if they do cross. If it has only one solution, that proves it's a tangent to the curve. So a typical question might be, find the tangent to this curve, given that, or show that this line is a tangent to the curve, and then you just equate them and show that the quadratic that you solve has only got one solution. Okay, so I found an exam question for that. It's down here. Here we are. So I want you to have a go at it. The fourth part is about the circle. So here's a line with some couple of points, and just find the equation of the line. Okay, so we need two things for that: gradient and the intercept. So you can figure that one out. You can skip part 2 if you want, and part 3. A circle passing through A and B has its centre on the line x equals 3. Find the centre of the circle, hence find the radius and the equation. So x equals 3, and bearing in mind that you found what the equation of it was in part 1, you can just put that into the equation and get y, and then your xy coordinate is going to be 3, and then whatever you got for y for the centre. Hence find the radius and equation. So because it's passing through A and B, so 3 is probably like here somewhere, halfway in between. It must be passing through A and B, like that. We can figure out the radius because I just need to figure out how far it is from here to here. So how are we going to do that? How are we going to figure out this length? So I'll let you have a go at that. And that's going to give me the radius. And once you've got the centre and the radius, you've got the equation of a circle, because it's just Pythagoras' theorem moved right and up. Because x squared plus y squared is the radius squared, but that's only for the origin. But if I move 3 to the right and then whatever y is up, I need to just do that adjustment, which is what we looked at the end. And that's very similar to the completing the square of translating a function. Okay, hope that all makes sense. Please give me feedback and your answers. And if you've got any other questions in the meantime, please remember, use me. I hadn't heard from you for 2 weeks, and I was wondering if maybe things have gone off track or whatever. So we haven't really got time before December now to be wasted. So please use me as much as you can, okay? I'll see you next Monday.